Okay, so wonderful. So like Renata just said, we have received a um, new grant for a NSF National AI Research Institute on Adult Learning and Online Education. The institute was launched on November 1st, so it's all very, very recent, about 4 months since we got the grant, since we launched the institute. And let me just introduce what the basic problem is that we are trying to address. So in the United States in 2021, about 25 million Americans left their jobs. November alone, about 4 million Americans left their jobs. And there are all kinds of reasons for that. But one of the reasons certainly is that people are not necessarily interested in continuing their jobs as they were. This is a great resignation going on. And people are looking for upskilling and reskilling. These are adults, they have families, many of them. So many of them have homes and houses, so they can't relocate to universities and colleges. They can't go to where education is. Instead, we need to find now ways of taking education to where they are, where they live and their work. And that becomes a new challenge. The World Economic Forum, before the COVID-19 happened, in 2019, the World Economic Forum projected that there will be 133 million new jobs in the United States by 2030. This number is almost surely a lower count now that COVID has happened. So what do we do? How do we help these adult learners, millions of them, upskill and reskill? How do we take education to them? So that's the big challenge for us. Now, this, of course, is a very big problem. But what we want to do is to see if we can use AI to help in the process. So we want to connect foundational AI research to the unique circumstances and specific science of adult learning and online education. The reason for online education, of course, is because these are remote learners, they're distant learners. Now, one of the difficulties in online education that we all are familiar with, because we all have taken part in it either as teachers or students, and sometimes our children have taken part in online education. One of the difficulties with online education is that the quality of online education is not always very good. Certainly, it's not as good as in-person education often is. So how do we use AI to improve the quality? So we are interested not just in quality, but in availability. We want it to be education to be available to everyone. We want it to be affordable, and that's what online education promises. And we also want it to be achievable in the sense that people taking that should be able to succeed in it. They should have the resources available that they can succeed, teaching assistants, for instance. So the approach that we are taking to this is a social technical system approach, which is kind of new for AI. It's sort of old stuff in social sciences, but kind of new to AI. AI usually tends to optimize AI algorithms. And we are trying to make a move away from that. We want to optimize humans. So AI and humans working together, but it's the human, AI here is in the service of humans, and it's the humans whom we are trying to optimize using AI in some way. And that raises issues of accessibility, personalization, scalability. And interestingly enough, some of these issues occur not only for education, but also for AI. How do we make AI personalized? How can anyone in the world, whether teacher or learner, create his or her own AIs in a manner that does not take too much time or too much expertise or too much labor? So the entire approach is to bring education researchers and AI researchers together and thinking in terms of the socio-technical system. Here are some of the innovations that we are aiming for. Now, these innovations are driven by needs of education. So they are innovations in AI, but they're driven by education. So one of the things that often happens in online education is that there is not enough cognitive engagement, or there is not enough teacher presence. In an in-person class, you can ask questions to a teacher. In an online class, it's very difficult to do. There is very little social interaction. One of the biggest problems in online education at Georgia Tech, for example, but I think it's all across the country, is that students complain of social isolation. And that social isolation and lack of teacher presence can create serious mental health problems. So how can we use AI to improve engagement in teacher presence and social interaction? So just to take an example, can we use AI to connect people in an online classroom and say you are all interested in a particular hobby, or you have children who all go to elementary schools. So ways of connecting people in that we have not previously imagined, but AI can help do that. One of the things that is going to come out of this is, and this is one of the primary goals, is to think in terms of teachers, learners, and AI agents working together with information feedback loops between them. So teachers teach, and I'll get into this in a little bit more detail in a minute. So teachers teach and learners learn, but that's not enough. We want to collect huge amounts of learning data, build generalizations from them, and then feed them back to learners and teachers, as well as AI cognitive assistants who help the teachers and the learners. Now, on the right side of the column are some innovations in AI itself that I'll mention very briefly, because the focus of this particular forum is on education, not so much on AI. But how can we personalize learning in online classrooms? So one of the big advantages of online classrooms is that we have access to huge amounts of data that often is not available in an in-person classroom. So can we exploit this data to provide very personalized feedback? So this particular student is having a difficulty with lesson number 14, and that particular concept and we provide feedback when needed, as and when needed, personalized for that student. And that capacity can be done, it becomes available with online education, and is typically not available with large classes, in-person classes. Machine teaching is the idea where teachers and learners can teach machines themselves. So you don't have to be an expert at AI in order to be able to make AI agents work for you. Mutual theory of mind is the idea that humans understand how the AI works and AI understands how the humans work. So it is a mutual theory of mind. And finally, whenever we are dealing with AI for humans, there is an enormous need for responsible AI. There are all kinds of issues about biases, about diversity, equity, and inclusion, about a variety of different kinds of stakeholders. And so we want to do large-scale personalized participator design to be able to tackle some of those AI ethical issues early on. So one way of thinking about this, because of course AI has been used for education for a long time, the notion of intelligent tutoring systems has been around for a very long time. So that's shown here in the middle, close to the sort of 0, 0, 0 axis here in the XY dimension, that's ITS. Intelligent tutoring systems typically deal with handcrafted knowledge for very well-defined problems. For example, problems in arithmetic, 7 plus or minus 5 is equal to 12. Those well-defined problems which have a single answer, that's where AI has previously succeeded. We want to look in the horizontal axis here for complex problems, ill-defined problems, for example, scientific thinking or systems thinking. In another dimension, in the Y dimension, we want to think in terms of not just one learner interacting with a machine, because that's not how learning occurs typically. Learning is a social process. So how do we enable a community of learners to engage with AI and with each other? And finally, like I mentioned, not just handcrafted things that only AI experts do, but it's human taught so that anyone can do that. So those are sort of big picture goals here. And this is what the feedback loop that I was talking about. So usually, in online education, teachers begin with some notion of how learning will occur and the constraints and affordances of online learning environment, and the teach and learners learn. But now, because of online education, we can collect a lot of data and do feedback. So now we feed it back into teachers and learners and AI agents in an unprecedented manner that does not occur in in-person classes. And our hope is, our expectation is that by doing this kind of feedback of information, we can increase the quality of online education, improve it to approximately the level of in-person education, or perhaps even better. One of the things that connects with so much with the notion of NSF South Big Data Hub is that we'll be collecting data from overall over the entire period of the 5-year period of the Institute from about 2.5 to 3 million learners. This will be, we believe, the largest data set, data repository of adult learning anywhere, we think in the world, but certainly in the country. And we want to build this in such a way that within the bounds of privacy and anonymization and protecting student rights, this is shareable with the learning community as a whole, not just within our institute. So we'll build safeguards there, but within those safeguards, we want it to be available as a sort of public resource. So for example, any learning science researcher can send his or her algorithms to us. We'll run them on the data and send the results, aggregate results back so that we are maintaining student privacy. We will be following the sort of typical design-based research methodology for this. So these days, sometimes some people call learning engineering. So you do interventions, you do formative and summative assessments, frequent of them, and they sort of repeat the cycle. So I'll not talk a lot about it. Within a 5-year span, we think we can do about 13 to 15 such cycles, each cycle taking about a year. The first part being on design, the second part being on deployment, the third point being on assessment. Right now, these are the sort of core design elements that we are thinking of. And I think it's important to emphasize that one of the things that makes this really difficult and challenging, but also that's why it's so exciting, is because there are a number of things which are interlocking. They all have to work together right. So we can focus on any one of them, and for instance, AI technologies, and we can make it work. That's very interesting, but by itself not of much use unless those AI technologies are working together with learners and interaction and participatory design and educational context. And all of those things making them work together well is a really difficult challenge. That's the challenge for the Institute. So that, of course, requires that we have really good test beds. Usually when people do this kind of research, they do it, at universities like Georgia Tech. But we are deliberately focusing at the Technical College System of Georgia as one of our test beds. We have several test beds, but we are beginning with the Technical College System of Georgia, TCSG, which has about 300,000 students. And the reason for that is that the demographics there is dramatically different than, say, at universities like Georgia Tech or Georgia State or Emory University and within the state of Georgia. So that creates its own challenges. How do we build robust generalizations, learning models, and learning techniques that are meaningful to all of those demographic groups and educational contexts that often historically have not received as much attention from AI and computing as other groups have? So we have assembled a team, and this particular team has a number of universities. So they're on the left here, as well as industrial partners. They're on the right here, as well as nonprofit organizations. The prime here is Georgia Research Alliance, but the institute is headquartered at Georgia Tech and sort of kind of Georgia Tech centric. And we have assembled a team of several researchers, and these researchers come from both AI in the top row, as well as education researchers in the bottom row. And in the middle row are researchers who are in learning technologies, and they sort of interact both with AI and with education. So let me just end by sort of sharing that we have a website where you can find a lot more information about it. And we are extremely excited and passionate about this particular challenge. So really looking forward to it. I'll stop sharing the screen now and
Thank you, Ashok. Are there any questions? I mean, this is exciting, things to me. I'm excited. So is there any questions for Ashok? He might has time for the next 10 minutes. I think he might have to leave a little early. So if we want to ask questions now, I know sometimes we do at the end, we're going to stop and do it now. So you can unmute and just ask.
Good morning. This is Mark.
Hi, Mark.
From UVI. So when you will know if you succeed in this project, what are you eventually assessment?
So that's a great question, Mark. Thank you for raising that. So there are many ways of answering that. I'll share a few of them that we have been thinking about. One is to do quasi-experiment analysis. We can have in-person classes and online classes, use the same instructors, same content, same assessments, and see whether the in-person students are doing as well as the online students and the other way around. So that's one way of pointing out to showing that, in fact, our technologies help improve the quality of online education to make it on par with in-person. Another way of doing this, of course, is randomized controlled trials, which is a sort of standard way of education. But there are other ways of having measuring, I think what you're saying as well. So for example, how many people can we reach? Georgia Tech has an OMSCS program, which has become quite famous. And we are very proud of the fact that it has 12,000 students in it. That's just awesome. On the other hand, 12,000 students is a very small number compared to 25 million Americans who left their jobs last year. So can we reach, instead of 12,000, 120,000 or 1.2 million learners in 1 year? So that's another way of measuring whether we have succeeded. Does that help answer some of the question, Mark?
Yeah, sure. Thank you.
Anyone else have a question? Yeah, so we have one in the chat. Can you elaborate on the type of feedback researchers might get back if data content were shared with the project? Data and content were shared with the project.
Yeah, so that's a great question, not something that we have a full answer to yet. And this is something where we welcome input. So we would love to hear from you about what kind of feedback would you like to see? Would the learning science and education science community like to see? So here's just the beginning of the thought process that we have been engaged in. So within our AILO Institute, there are sort of 25 researchers, core researchers, and they definitely will look at the data and run algorithms and build generalizations, for instance, learning progression or learning trajectory, or trying to find where a particular student needs help, or trying to find what kind of feedback should be given to that particular student. And we will do our best, but I'm sure that 25 is a very small number compared to the learning science community as a whole, which has, orders of magnitude more researchers in it. So we are very open to learning from you about what kind of algorithms would you like to use, and what kind of generalizations do you want to extract out of them, and we'll try our best to support it. So you tell us, please, what you would like to see, and we will try to do what we can to see whether we can help you run those algorithms and those generalizations.
Is there another question? Teresa?
Yeah,
Hi.
actually it's not a question, but this talk matters a lot what I'm researching, that is educational data mining. And I'm very interested to know deeply some projects, and I'm available. I am a scholar visiting in Georgia Tech.
Oh, that's wonderful. Yeah, great to meet you. So, so it's good that Renata and Kendra have this particular page where everyone is putting down his or her information. If you'll put it down, please, then we can contact you, and feel free to send me an email. So that's another way. And right now in our AILO program, we have a core set of researchers who wrote the proposal and sent it to NSF. But very soon we'll be starting an affiliate program. We're not quite there yet, where anyone can join the affiliate program. We'll welcome your participation because this has to be a process where we have to engage a larger community and not keep it limited to just 25 researchers.
Great. And will it be online? Because I know, Teresa, you're going back to your home institution as she's visiting at Georgia Tech, but so others outside of the area too can do the same. Yeah.
Yes, indeed. So this is intended to be a national program and not limited to Georgia Tech or the state of Georgia or anything like that. So.
Great. If someone doesn't have a question, I have one, but if someone has a question, go ahead and ask away. Well, while people are thinking though, you were talking about human being able to design their own AIs. How do you envision that working, like the actual students being able to design their AIs, or the faculty involved, or the researchers down the line? Like which group or all of them are you envisioning that will be able to do that?
Yeah, Renata, great question. We're especially interested in teachers.
Mhm.
I think learners may come later, but first we want to focus on teachers. So what happens is that we can create an AI technology, but teachers will not use the AI technology unless they can develop their own AI technology. So, this is a finding. AI technologies often fail because they can do something interesting, but nobody uses them. They start using pen and paper again because to use the AI technology itself is an upfront investment. And if a teacher has to make upfront investment of 50 hours, teachers are so busy, no teacher is going to spend 50 hours of his or her time in the first week of classes and they hope that this AI technology will help them later. So we have to make it so, we have to make this teachable so that any teacher can teach the AI technology about the way they want it to be done. And we have to do it in such a way that a teacher can do it not in 50 hours or 500 hours, but in 5 hours or half an hour. And that's the challenge. So that raises a different set of issues for AI. How do we democratize AI and how do we make it teachable and tunable so that any teacher can do it and he or she doesn't have to be an expert in AI? We don't know how to do that, but that's one of the challenges. When I say we don't know how to do that, we have research projects going on, of course, otherwise we would not be thinking about this, but we haven't completely solved the problem yet.
We can put, I think Vera, this is a different project that you worked on before that was very much focused on an AI to help researchers and kind of bringing in that data. So we could put that link in there too. It's an example. It's not in the education space, but it's definitely AI made easy for researchers. And that was a very interesting project as well that Ashok was looking at in his Spoke project.
Will do. So I'll share a couple of links, both to Vera, and you had mentioned Jill Watson earlier. There was an automated TA that answered questions automatically in online classes. I'll share links about both of them.